Hi everyone, that's the second section of the information visualization with the Gephi software. In this section, we want to create high quality rendering from the data sets of the COVID-19 cases across the whole United States at the county level. So again, you could just go to our website that I sent to you, the links here shown here, and then the aim is to create a high rendering visualization for the whole United States for this data set, or reproduce this graph here. So similar to the ones that we had in the previous section, which was just for the introduction and working with a really a smaller data set for the state of the South Carolina. But now we want to move to a more challenging data sets for the whole United States and put the data of the number of the cases of the COVID-19 and the number of deaths of the COVID-19 across all the counties in the United States and create high rendering quality. So high quality rendering for the graphs and networks. So again, we start similar to the previous section by opening the Gephi software. Just click on the new project. And again, similar to the previous section, go to the data laboratory, click on the import spreadsheet, and just click on the data.csv file that you downloaded in the first section. So remember, you need to just download 4 different files: data-sc.csv, data.csv, nodes1.csv, edges1.csv. So those are the 4 files that you need to download from our website to be able to follow this workshop. So here, the data.csv just contains the data set of the COVID-19 for the counties across the United States. So just let's, similar to the previous section, click on the open. Again, you see the path of the file, and it's a comma separated format for the separator. And because again, in this data set, similar to the previous one for the state of the South Carolina, we have just only the nodes and there is no edges, so we choose the nodes tables. And click on next. Similar to the previous one, the county and the estates are just the string variables, so we choose the string for the county and estate. And the latitude and the longitude are just the double variables. And the number of the cases and the number of the deaths, similar to the previous one, are just the integer numbers. So make sure you choose the county estate as the string format, and latitude and longitude as double formats, and the cases and the number of deaths as integer values. And then click on finish. So you see that we have 2,750 nodes. There are some missing nodes for some counties because some of the counties have 0 number of cases or 0 number of deaths. So that means we just excluded those counties in our data set. So that's the reason why this number doesn't match exactly for all the number of the counties in the United States. So finally, just click on OK, and we just loaded the data set successfully here. And similar to the previous section, just go click on the overview. So that's the general graph that we got. And you see that even in this one, it's more challenging to find out at the first glance what's inside in this graph or network and what's the information that we want to extract. Similar to the previous section, again, we know that each node represents the counties, so we could rearrange the graph based on the longitude and latitude. So go to the layout, choose the geo layout here. Just choose the geo layout, choose the latitude, longitude, and make sure the projection is Mercator. And I would choose a different number. For example, I would choose the 5,000 for the start, but you could just always change that based on the final appearance or the arrangement you got from the Gephi. So just click on run, and that's the final configuration or the arrangement that we got. You see that maybe it's possible to make it smaller by decreasing the value of the scale. So I would choose 2,500 instead of 5,000. And you see that it just makes it more concentrated. And just up to you. You could just whatever you want to choose. And the similar to the previous section, I would just put the color and the number of the cases and the number of deaths as the color and the size of the node, similar to the previous one. So we will move on here a little bit more quickly, but just feel free to ask questions if you have any question here, or just repeat the first section to just make sure you are familiar with the how to configure the color and the size of the node and put some labels. So I will just move on more quickly here by just clicking on the color, going to the ranking, and choose the cases. And I would choose this one to show the low number of the cases as the blue and higher number of the cases as red. And just click on apply, and you see that because we have some outliers in our data set, and clearly you see that the New York City, which is located here as a red spot, is a clear outlier in our data set. So that just means the data is not distributed linearly across all the counties in the United States. So we need to choose a more appropriate distribution. So back again to the spline configuration and configuration rank interpolation, and I would choose similar to this one, which is a really strict exponential distribution. So let's see what would happen. Okay, so now we could see where are the red spots. So clearly we have some concentration of the red spots for the number of the cases of the COVID-19 near the New York City here. We have the other spot near the Miami in the Florida. We have some other spots near the New Orleans in the Louisiana, Houston in Texas, probably Chicago, and clearly the Seattle in the Washington state, and the Southern California or the near the LA County here, which is shown again, shows as the red spot. So that's better for the visualization of the high concentrated areas in terms of the number of the cases. And that could be achieved by just changing the distribution of the data and just define, okay, my data set is not distributed linearly. And let's see, I just choose a really strict one, but see if we could choose a different one. Okay, so that's a really crazy one. And let's see what would happen if we choose this one. Okay, so the best one for the distribution is the exponential one. That just makes the graph more meaningful. And let's move on to the size of the graph for the nodes, size of the nodes. And again, we want to just put the number of deaths as the size. So I start with 10 to 20, but that seems those are pretty low. I would go to 100 probably, but that's a bit high. Okay, so let's see. It's a bit high, and that's better, but it's up to you to just choose whatever you want to choose here. But we know that the number of the deaths also is not distributed linear. So again, we come back here and we choose the exponential distribution and click on apply. And you see that clearly we could see the red spots as New York City, Chicago, Miami, probably the New Orleans, because there are some concentrated data is not clear how we could detect that. The LA County here and Seattle in the Washington state. The more interesting way, for example, because we have the data of states as well as the graph. So now we could just see how we could put the labels for the states or the counties, but that just makes the graphs too busy, so we don't want to do that. And we could just come here again, similar to the previous one, to just change background. So that's the final visualization that we created for the whole data set of the COVID-19 across the United States. Based on the number of the cases that we have, it shows the colors and the number of the deaths, which are shown by the size of the nodes. In order to create a high quality rendering, you need to just click on the preview here, go from the overview to the preview, and let me just make it better here, and click on the refresh. So you just create a more quality rendering for you. And then you could just change the background here and just let me bring the graph to the middle. Yeah, so that's the final graph, the high rendering visualization of the COVID-19 data set across the United States at the county level. So then you could just take a screenshot, or here you could just save or export this visualization as as a SVG, PNG, or PDF file. So you could just take a screenshot from here, or just export it as the SVG, PNG, or PDF file. So that's the one that you could just use for creating high quality rendering. So that was just for uh, working with the second data set of the COVID-19 data set across the counties of the United States. So I hope you enjoy the workshop, and see you in the next section.